here live, ready to go whenever.
Okay, welcome to our weather discussion. Shut the door a little bit to direct the fan more at me. I guess I'll leave that open. We got a lot to talk about, my friends. It's I don't know where to start. I guess we'll start with this image since it's up here. This week we just saw it. We'll come back to it. That's okay, we'll come back. We had Hurricane Otis that developed in 12 hours from Tropical Storm Otis to Category 5 Hurricane Otis before effectively destroying Acapulco, Mexico. And I think already now 30-ish people have lost their lives. Acapulco's almost 100% tourism industry is destroyed, and it's going to be a long time to get it back. But there's Otis making, as soon as it makes landfall, it's a mountainous part of southern Mexico, of course it disappears, but it developed right off the coast from tropical storm strength, which would have been, a notable storm to begin with, to Category 5 hurricane strength. The community is confused about how this could happen. I guess the ocean temperatures off the coast, sea surface temperatures were around 85 to 88 degrees. So that's certainly a factor, but it can't be the only factor. The water can be warm without, the development mechanisms going on at the same time. So there's got to be something more to that. We're going to have to learn that as we go on. I certainly won't be learning it. I'm not an expert in that stuff. But it is fascinating and disastrous nonetheless. It's just an amazing event. And I'm sure we'll hear more about it. Perhaps even people in this room will do research on Otis as the months and years go by. So let's look one last time. Here it is. Watch the eye just pop out of nowhere, boom, hits the coast right at Acapulco. And I guess the stretch of coast there has not got tons of cities on it. So you could have been in between cities, but it wasn't. It was right on target. So what a disaster. Meanwhile, over the continental United States during the same week, while we've got this up, we've had a passage of a couple of different weak storms over us. Each time precipitation has been part of the equation. This, I think, is Tropical Storm Tammy, which never got to hurricane status, and we'll see it at the end of its life, at the end here, as a tropical storm. It always had sort of an extratropical look to it. But we've had a parade of disturbances coming across the high northern plain states for reasons that might become clear when we look at the upper level charts. There's really been kind of a zonal, slightly southward directed flow across the northern plain states, but a strongly baroclinic one. And that is the cold air is well to the north. Much of this colored cloud here is just cold air. It's not anything more than just air at the surface like that. It's very long lasting air, cold air and snow showing up as light blue here in the infrared. So we are about to have a major change in our weather, as I think we're all maybe even hoping for. But let me just tell you this. Last night was the warmest overnight low in Madison after the 25th of October. And I just chose that date at random. I could have gone further and really kind of, sliced it. Maybe it was the 20th of October. But anyway, the 25th of October since 1946, nearly 80 years ago, when it was 64 degrees overnight on October 27th, 1946. And we, the next nearest competitor was Halloween night on 1974, 61 degrees. So last night, I think about 7 or 8 o'clock, it was 63. Temperature went up to 66, then back down to around 65. So it wasn't exactly the easiest thing to decide what was the overnight low. But even with the 63 at 7 p.m., we beat that second place by a good margin and almost got into first place. But certainly the warmest overnight late October day in almost 80 years. And here we are all sweltering. Me more than you. I'm keeping up the standards, even though it's hot. So that's pretty unbelievable. For the month, we're 3.5 degrees above normal. And it might not sound like much. The interesting thing, I've been doing this a little more when I look at such things, is you cut them in half. What's the departure from average for the highs of the day, and what's the departure for average from the lows? And the lows are 4.5 degrees warmer than normal. And the highs are like 2.1 degrees above normal. So average is up to 3.5, whatever that is, if the number's not right. It's just because I'm not reading them right. So most of our surplus in temperature for the month has been accumulated overnight lows. And it's not surprising since we're here on the grandest morning after of that overnight low that we've had in 80 years. So pretty incredible situation going on. But it's not going to last. We're going to get colder. And I think the way that I want to present that is, let's first go to, since the satellite movie encompasses what we're looking at across the continent already at the current time, even though it goes back to prior times, let's go first to the surface map, Pete, the big surface map. zoom in a couple of different places. In class this week, we've been watching the evolution of a deep upper trough over the western part of Canada that's kind of nosed southward into Montana and into the Dakotas. And you can see some of the, let's go a little higher so we can see some of the states too. Right, perfect. So we've got some light snow in northeastern North Dakota, same thing with northwestern Minnesota. Moderate snow earlier today at Pickle Lake in Ontario. It's gone back to light snow. So once in a while, I guess these bursts will be a little bit more than light, but it's widespread. And we're going to focus in on that. So it's kind of a region sort of centered around International Falls, Minnesota. And then look at some of the temperatures to the west. It's gotten very cold. It's still snowing in western Montana, because that's probably some orographic lift or something that's doing that. Look at the temperatures. They're in the teens, dew points in the single digits. This is really cold air. It's the first really cold shot of air all year round. And we can see the temperatures in southern Alberta and southern, well, not so much British Columbia, but southern Alberta are pretty cold, and southern Saskatchewan the same thing. Really chilly air and snowing in some of these places as well. So kind of a desolate look, I bet, across the southern prairie provinces and the big sky country today. But nonetheless, an exciting one if you're me. Because, you know, I want snow on the ground here, because I want that radiated blanket before November 1, so that the next time one of these comes by, it gets a little bit of extra cooling at night before it comes in for us. So I'm kind of excited about that. And we're in the vicinity of a really substantial temperature change. Look at this, 69 over 60, 69 degrees on the 27th of October. 19 years ago today, I was watching the Red Sox beat the Cardinals 4-0 in Game 4 of the 2004 World Series. I was there, and I have a ticket stub to prove it. Of course, everybody from Boston says they were there. I can prove it. And it's the first time I ever used a cell phone, because I called my dad after it was over. I said, "Dad, we did it. It's unbelievable." So that was wild. It wasn't 69 degrees. It was kind of drizzly and in the high 50s, low 60s. Didn't stop our team, did it? Look at the southerly winds, southwesterly winds. Then you go to Dubuque, 57 over 54. Temperature drop of about 12 degrees, dew point drop of a similar amount. Go further back in Iowa, by the time you get up toward like Storm Lake, it's 36 over 30. And the winds are howling, 20 knots. These are sustained winds that are plotted on this map. So this is a substantial cold front coming through here. We're going to look at some Oklahoma mesonet time series, where the winds are also strong. If you go a little bit further north beach, if you get all the way down to the southeastern corner of Oklahoma, you still got temperatures near 80. But in the rest of the state, they're in the 50s. The dew points are 20 degrees lower. You might guess that this all occurs over a period of hours. You would be wrong in that case. You can see these drops in 10 or 15 minutes of 15 degrees Fahrenheit. It's unbelievable. In the flat plains of the central part of the state of Oklahoma, which by virtue of, you know, its tornado frequency, being the heart of Tornado Alley, has a long-standing mesonet. And wait till you see some of the density in it. You can go and play with it yourself, but I'll show you a few things today as part of the discussion. But look at the wind shift across this front. It's remarkably obvious where it is. And the temperature drop, the whole thing. And it's a weak cyclone up in the northern part of our own state to which it's connected. But it is not hard to find the frontal boundary. Look at this in Missouri. That's near Joplin, and that's further to the west of Joplin. 18 degrees and 12 degree dew point drop across about a 110 degree wind shift. So it's easy to see this front today. So, you know, there's people, I won't mention who work at the University of Washington who don't think there's fronts. There's a number of them, some now deceased, who are really great souls. But they didn't believe in fronts. I'd like them to stand right here this afternoon for a number of hours, somewhat exposed, maybe in the Bermuda shorts and a t-shirt, and tell me that later tonight. I don't think they would. Okay, let's go now, then, Pete, to the Oklahoma mesonet, which I have set up. Right. First of all, I texted Michael about this. This is a high-profile page, which is showing meteograms. I think there's a dispute to be had. And so he's kind of constantly, as you know, giving me grief about the fact that this is a better word. It just kind of flows off the tongue rather than putting that R in there, meteorogram. Why would you do that? Oklahomans don't do that. And they have a really well-funded mesonet. So these are station meteograms. I haven't heard back from them yet. This is a 24-hour time series at a station in Spencer. We'll change them in a minute. But look at this. Temperature in red, dew point in green. And I think, Pete, you can drag the mouse along and it'll tell you what's going on at these places. Yeah. So let's go right to the peak here. Find out what time it was and what temperature it was at Spencer, Oklahoma. So this was 6:20 a.m., temperature 73 degrees Fahrenheit. Let's go ahead a couple of increments. So 6:20, one more, maybe this is now 6:50, 30 minutes later, 63 degrees. Okay, keep going. Now we're like almost an hour later and the temperature's gone down to 55. So in 1 hour, we went from 78 to 55. That's pretty incredible, but maybe not the best one. Let's change the station. You can do this without being blind about it by looking at another map they have about the current temperatures, but somewhere in the middle of the state is where things were getting interesting. Let's take this one right here. I don't know what it is. Any of those peaks over there. That's Kingfisher, Oklahoma, the thriving metropolis of Kingfisher, Oklahoma. Let's see, it'll take a second to come up, but let's see what it looks like.
I think that's a bird.
Oh yeah, you're right, it is a bird. But it's also a thriving metropolis in the state of Oklahoma.
That's all it says.
Come on. You can see all the things you can dial up. It can be more than one day if you want, and then all the rest. So at Kingfisher, it was pretty similar temperature drop. Let's see what it was at, this is 4:35 a.m., so 72 for an overnight low. That's pretty warm. And then 4:50, let's see what happens. 10 minutes later, it went from 73 to 59, 13-degree temperature drop. No one's, well, maybe everyone's awake in Kingfisher at 5 a.m., but probably not everybody, but some people might be awake and noticing this. And then, of course, it levels off. Somehow the dew point trace didn't come in from Kingfisher. Let's do one more. Maybe get a little closer to this, right about here, because this is going to be up to date. And that is, oh, Holdenville, of course. Who could forget Holdenville? Whoa. Oh, I think we found it. All right, Holdenville at 10 o'clock this morning was one more peak. We want to get right to that next click. Yeah, 73.3 at 10:05. What was the temperature at 10:20? One more. It was 61, 14 degrees in 15 minutes. That's a degree Fahrenheit per minute in the mid-morning. That's pretty unbelievable. So anyway, you can have a lot of fun with this. This is a legitimate cold air invasion in the central part of the United States. And you can really see how intense it is when you look at the Oklahoma mesonet and just have some fun playing around. And as I said, you don't have to do that blindly. You can look at a broad map of the whole mesonet network. I think if you go right to the top here, for instance, or just click back even. Maybe that doesn't enough. Not sure if it does. Yeah, the home page. One more click back. Because I can go here. Maybe one more, sorry. It's a little bit arcane how they organize it. But here you can see the map of the whole state. So you'd really want to stop looking at stations right in here. So you can do it without being blind about it. But look at it, even just looking at the odds. Overall, mostly near 80, and then it comes to precipitation. There'll be a band of precipitation that comes through here in the next clip. It goes by itself if you don't force it. One more is the precip, I guess. There it is. It's right along the front edge of this thing. It's really a beautiful data set, and you got a lot of fun with it. Mitchell.
So today I learned the founder of Walmart was born in Kingfisher, Oklahoma.
Is that right?
Yep.
I told you it was a thriving metropolis.
And Sandsville as well.
So there you go. I told you that. I didn't know that, but I told you nonetheless. Okay, thank you for that, Mitchell. Let's take a look now at our upper level charts. Remembering that there's snow in southwestern Ontario, northern Minnesota, and kind of take a look at the eponymous superpeaks. He even forgets where they are now. Okay, let's go to 500. Not the loop, just the image. I don't want to do the loop. It's too hot to do the loop. So this is 12Z today, and you can see, look at these temperatures in the middle of this cold pool. Minus 31 at Churchill, minus 28 north of Lake Winnipeg, and this is the minus 30 isotherm. It's minus 34 in Spokane. Maybe it's minus 40 or minus 35 isotherm. This is minus 30. Sorry, I had it wrong. That's minus 35. That's as cold as we've seen all year round. All year to this date, I should say. So that's very, very cold air. And it's cut off. It's not really connected to the minus 35 up in the archipelago. Who cares? You know, beggars can't be choosers. It's late October. Here's a little bit of a wave coming right across the border between North Dakota and Minnesota, South Dakota and Minnesota as well. And we're going to watch what's going on here. Remember, this is 12Z this morning, so we're going to look at some charts there at roughly the same time. Broadly speaking, you can see there's a broad confluence pattern across the eastern part of central Canada and the northern part of the United States. reasonable baroclinicity. Again, this is the minus 30 isotherm. This is the minus 15 isotherm, I believe. Yeah. So there's pretty good confluence on top of that horizontal temperature contrast, especially at the longitudes of Ontario and Hudson Bay. And so that's accounting for the cloudiness broadly that we saw in the satellite picture. Let's go a little bit lower for the time being, maybe 700 millibars. And you see the same confluence zone and a similarly strong horizontal temperature gradient. The red lines are isotherms every 5 degrees, so we're seeing the same gradient, but just at a different elevation. And that is, again, frontogenetically active. At the first glance, you can tell that. So the axis of dilatation of the flow is right along this, the axis of contraction is like that. And so we're getting a squashing of the isotherms. And when you get to the lower troposphere, you start to see that baroclinicity acted upon frontogenetically even to the west of the minimum in the geopotential height. So this is where the cold frontal structure that we're kind of watching make its way through Oklahoma in the details of the surface observations has an upper level structure to it. Okay? And that's frontogenetically active. Look at the winds at like North Platte and at Minneapolis. They're more or less parallel to this plus, I think it's a 0 degree isotherm. And then all the winds over the Dakotas are perpendicular to the colder isotherm. So that area is being advected southwest, eastward, and this area here is not moving in any direction away from it. So that's a squashing of the isotherms as well. Thermally direct circulation's the response. There's no way you can't do that. And where there's a coincidence of such frontogenetic activity with another type of dynamics, that's where you can really get some interesting weather and some heavy weather. And we saw moderate snow earlier at Pickle Lake at the Stowing in Ontario. Okay, how about 850 people? One imagines that the baroclinic zone gets a little bit lengthier the further down in the troposphere you go in a case like this, and sure enough, that's the case. Look at how intense this is. This is 20 degrees difference from the warm edge to the cold edge, all the way down to the panhandle of Texas and into New Mexico. And we're watching it at the surface a little bit further to the east in Oklahoma. And that's where we had that boundary, I think, in the last moment at the from the mesonet. So, you know, this thing doesn't have a great slope. They tend to be quite shallow by the time they make their way that far south. But it has some slope to it. I mean, it does have a great slope. It's not steep, I should have said. It has a pretty intense slope. It gets cold at 850, well to the west of where it's getting cold at the surface, because it's kind of a pancake-shaped cold air invasion. But along this whole baroclinic zone, it's frontogenetically active, with ascending air most likely occurring on the warm side of this baroclinic zone. And then other things going on here in southern Ontario. So a little bit of a departure from our normal way of looking at things. Let's now look at the radar and see whether or not any of those things that we suspect were occurring are actually occurring. And there's that little thin line of precipitation that we saw on the mesonet that extends through Missouri. It's not really that intense of a precipitation band, along with a fairly intense cold front. So that's worthy of some subsequent investigation. How come we're not seeing anything more substantial along this? One guess I have is that maybe it's just not sufficiently moist air, or there's some other, you know, discouraging characteristic of the environment that's not obvious to me. But anyway, there is a thin line of precipitation kind of right along the front edge of that boundary at the surface, and then things off to the east that I think are not directly related to it. And we don't see anything in southern Ontario just because there's no radars in Canada, but I think there's snow falling there, as we saw in the surface. So I think the last thing I want to do is let's go to the forecast panels. Since we've looked at the 500 milliwatt chart already with the real observations, I'd like to do that first. But now let's go to a 12-hour forecast. No, it could be a 0-hour forecast. It's probably better. From
Our pager.
Yeah, it could be our page. I'd like to get one that has a reasonable depiction of the vorticity of 500 millibars. And reasonable might be
12C 00.
60 and go to 6-hour forecast maybe. But what I'm kind of worried about is the resolution. Oh, it's okay. It's high resolution, but you can certainly see the feature of interest. Just right on top of International Falls, Minnesota, and this broad upper wave that we saw in the 500 millibar, or this small upper wave in the broad context of the bigger wave, the leading one here over Minnesota. So can we go to smaller, not the 104 grid peak? Can we have something like that? Just because it'll be easier to see the spatial relationships.
Perhaps.
This will be a good enough case, even the NAM will give a pretty good picture of it. Let's see what this is. So this would be 0-hour forecast. Yeah, but it's old, unfortunately. So what about the dam? Let's see what the,
Here's the zero, this is zero.
oh, then 12, yeah. It's still old, unfortunately. Okay, that's good, thank you, that's better. Because we're kind of zoomed in, but it's roughly the same structure as you can see, and a little bit less intense resolution. So there's the maximum vorticity, right over, the Lake of the Woods area in Minnesota. But the important thing is a strong gradient of vorticity from really large values to weak ones over a small distance. Let's put the forecast sea level pressure map on top of this. And right there is where we had the vorticity maxima. The thickness lines from 1,000 to 500 are in yellow, so one gets the impression of really strong thermal wind cutting right through that vorticity maxima. And that's perfectly coincident with the heavy snow. It's accumulated snow over 12 hours or 6 hours. So it's kind of slid along here, but the maximum accumulation is right about where the strongest PVA by the thermal wind is. That's a really nice relationship that we see there. I'd like to also look at this time at 850 millibars and kind of see what's going on at the level there. So right over that portion of Lake of the Woods, you can see the winds are kind of parallel to the isotherms on the cold air side, and then you can't see the arrows, but they're pretty strong winds with some slight warm advection over Lake Superior. And then they curve around cyclonically. So there's presumably, I'm going to guess there's some decent frontogenesis going on in here too, although it's rather weaker than I would have hoped. It's stronger along this boundary. But that might also be contributing to some of the ascent that is in turn contributing to the snowfall over Lake Superior in southern Ontario. So that's fairly interesting. Let's do 12 hours ahead just to show this relationship is fairly robust. So there's our vorticity feature. It's changed complexion entirely. It's not as intense at 500 millibars, but there's still a leading edge gradient right over Hudson Bay. So let's see, I guess I'll put my poker right about there. Let's see what we find out with the surface map on top of that. And the thermal wind is still strong, as you can see the thickness line, so there's PVA going on, but that's not enough to explain the linear nature of this band, in my opinion. So I'm thinking the geometry of the forecasted precipitation's changed, it's become a little more linear. Let's see what it looks like at 850. And here you can see even stronger frontogenesis into Quebec and then back to the south across Hudson Bay into central Ontario. Particularly, winds are cutting across these isotherms right here with a fairly sizable intensity of the wind, and then suddenly they're parallel to the isotherms on the cold side. So that does nothing but squash the isotherm band together, producing frontogenetic response, and that's warm air rising on the warm side, and that's part of the precipitation band. And then the part back here where it's less frontogenetical is closer to the PVA by the thermal wind. So they're working in concert, even though they're fairly different dynamical forces. And I think that the cool thing about this, Hamish pointed out a paper to me by Andrew Winters looking at precipitation along the coast of Antarctica, where they're looking at the superposition in space of PVA by the thermal wind and the frontogenesis. And it makes perfect sense, it did at first hand when we're talking about it, that when those two forcings are coincident in space, that's where you're going to get the heaviest precipitation, because they both contribute in the same way, but they make their own separate contributions. And so I think that's going on here in southern tip of Hudson Bay by the time we get to tonight across that part of the world. Okay, the last thing, Pete, is let's just take a look at the omega plots. Remember, we've been looking at, the first time that I showed you was valid at 12Z today. So this is also valid at 12Z today. 700 millibar vertical motion. Look at that maximum. There's the Lake of the Woods right there, so it's right in the exact same spot. And then there's the subsidence on the upstream side of that little wave. If we split this into the Sutcliffe portion, which we slide down, we can get that right here. It's the same general picture, but it's a little more cartoony. That's just the nature of it because it's an approximation. But you don't get a different flavor of an answer. It's right on target. And then one last thing, since this is all the vorticity affected by the thermal wind, how about the shear vorticity? Oh, wait. How about the curvature vorticity? We know there's a curved flow there, so let's see if it's better. Yeah, it's a little bit better. So that's the one that's contributing more in that location. And I have this notion in my head that if you compare the grid points and the values of these separate species of the vertical motion, maybe at 700 millibars, like I'm showing you here, you could get an idea of, what's the prevalent mechanism for driving the cyclogenesis across the region. Maybe you make sure you only look at that comparison in a region where you know you have cyclogenesis going on, and you could probably end up constructing a picture whereby you'd know for a given cyclone, it's more related to the curvature of the upper flow than it is the shear of the upper flow, and the orientation of the shear relative to the thermal wind. And that might matter for large-scale circulation questions about differences between the hemispheres. I don't think it really matters so much for one storm to the next. But if you have a more zonal flow in the southern hemisphere, you might find a preponderance of shear vorticity advection leads to cyclogenesis, just because where's the curvature in the flow? It's not as curved. And I don't know if that's right or wrong, but it's worthy of investigation. So that's one last thing I just want to tell you, I'm not going to show you. That is, I only show you an update with the graph of the cold pool every 2 weeks. This last week we had a steady climb back to climatology. So we're right about where we should be on the 26th of October, yesterday. Despite that, we're still the second warmest September 1 to October 26th in the NSEP time series. So we were only third 2 weeks last week, now we climbed the spot. So it's alarming. It's too warm for the hemisphere this fall. And I don't know what that means for the rest of the fall and the ensuing winter, but we're all going to find out. So that's all I have. Thanks. Patrick's going to do the forecast. Pete, thanks for driving.
Thank you. Can we start with weather.gov, please, Pete? Then I'll go to our forecast model page and then end with a pivotal look at temperatures. So first, you can sort of track the front as it's moving over the Midwest and into the plains. Here's freeze warnings for tonight, stretching down from Kansas all the way to our region and back into Colorado. I looked up when they stop producing these freeze warnings, because we're going to be in the low 20s come early next week, and it's after the first freeze after mid-October. So we're past mid-October, we're going to have our first hard freeze, so we are not going to see many more of these freeze warnings. Our growing season's essentially done with this shot of cold air. And on the backside, you can see winter weather advisories, Idaho, Montana, the tip of Minnesota, and then into Nebraska and Wyoming. Largely speaking, this map does not do justice with the system that's going through, I would say, with the temperature and the snow and everything that's going on. And I want to point out, could we look at Pueblo, Colorado up here? I want to highlight two cities that this front also went through, not just in Oklahoma, because I think the temperature changes are remarkable. So we'll go to Pueblo, Colorado, which is in the far southeastern portion of Colorado. We'll go 3-day history. And let's see, okay, so this is yesterday. So temperatures started in the 30s. They rose all the way up to 81. And then you're in Pueblo, you're like, oh, it's a beautiful day. It's 77, calm winds, it's sunny. I'm gonna go for a run. Suddenly you have 40-mile-an-hour winds from the north. Temperature drops 15 degrees in 1 hour, and then another 13 degrees, and you're in the low 30s and cloudy. So this was one change in Colorado. So let's go back, and we'll go to Guyman, Oklahoma now.
Oh yeah, that's a good one.
Which I think was the craziest site I can see. G-U-Y-M-O-N, yes. This is in the panhandle of Oklahoma, one of the 3 cities that are in the panhandle.
You can get this every 5 minutes on the resume, it's worth it.
That's right. So let's see, yesterday, you're in the low 40s. You rise to 84 degrees. It's clear, there's a south-southwesterly wind, not too strong. And then we'll go overnight, it begins to rain, the front moves through, and if we could scroll up just a little bit. Then 13 hours later, it's snowing. So it goes from 84 to snow in 13 hours, which is just crazy to believe. And of course, this is not accumulating because the ground was 84 degrees today. But still, something that would be just wild to live for 13 hours, for more than one reason, but in the panhandle of Oklahoma. So this is a pretty crazy front and frontal system. So now, could we go to our model page, please, Pete? And I'll do the GFS look because I want the larger grid. And let's start, I think we ended with, is this the 12 run?
Yeah, it should be.
Okay, so let's start at 24 hours here at the surface. Okay, so we ended at 0 UTC tonight around 7 p.m. So this is tomorrow morning. We can see here's an obvious frontal feature coincident with the strong gradient in thickness. We can see there's a high pressure sitting over Montana. So with clockwise flow, we're getting strong cold advection indicated by the tight gradient of isobars and then the thickness line. So it's going to be a cold morning. Our front has very clearly moved through our region. Not too much precipitation along the leading edge of it. We kind of saw that right now, and that seems to continue. But this cyclone has strengthened. And so we'll look at that right now. We can see I think it's around 990. It was about 1,001 12 hours before. So could we go back and go to the 500 map? And I'll keep my cursor right here. So you can see right where the cyclone was situated, we have a decent gradient of vorticity. It was much stronger on the previous model run. There was a nice ball of vorticity right here. But there still is a gradient, and the thermal wind was cutting across it, and that was directly where the cyclone was located. And you can see the precip and the cyclone sitting right on that edge of PVA by the thermal wind. And then if we go back, I'll keep my cursor here, we'll go to 850 at 24 hours. Okay, so you can also see there's still strong frontogenesis where we have winds largely parallel to the temperature gradient on the cool side, and then strong southeasterly flow or southwesterly flow on the warm side. So two areas of the two processes leading to vertical motion right where our cyclone is located and our cyclone strengthened. And then you can see the obvious frontal feature well past our region at this time, reaching into the lower Midwest and into the south eastern part of the United States. This is tomorrow morning. So let's jump ahead 12 hours from this, and we'll start at the surface. So 36 hours. We can notice our cyclone has deepened. So now it's below 988. I can't really read the number there, but the frontal feature has not really moved that far. So it's sort of slowing down as it's progressing southward. It's kind of being more divorced from the actual system, I would say. Even though it's still tied to the system, the feature is well away. So you're losing the strong advection of all these temperatures. You still have a decent gradient in the isobars, so you're still having cold advection largely over the upper Midwest and into the Northeast. But once you get into the southern plains, you're running into a weak high pressure system that might be bringing some warm flow, some return warm flow, moisture, and it's sort of competing with the cold front. And we're going to see a stagnation of this front just over the weekend.
You know, I bet if you looked historically, Patrick, because you're right, the development to the east is pretty impressive. It took a while for the whole thing to get together. I think yesterday the sea level pressure minimum was hundreds of miles to the southeast of where the strong dynamics was, and it's finally kind of exactly in the right spot. But there's no, the geometry of the upper wave is really stretched out, and that means there's no upstream anticyclone development.
That's right.
And so you don't have anything to really push the cold air southward.
That's right.
You know, in the really strong cold air outbreaks, you have a good development to the east, and you have an anticyclonic development to the west, and that pushes that strong southerly flow across those thickness lines.
That's right.
Down to ruining, you know, tomatoes and oranges in Florida. That's not going to happen.
That's exactly right. Could we go back, please? I want to show this. I think that's a good point. Could we go back to the prior model run? I think it was the 6C one. Here's what I was looking at this morning. If we could go to 24 hours, I believe, at 500. Oh, no, it's still...
But that's even more compact than the one that we just saw.
Yeah.
But not much more. Yeah, you're right.
Let's go back. Let's go to 12 hours. I won't go further than this. Whatever I was looking at, I have no idea. There was a nice ball of vorticity at the 24 hours, so it was strong PVA, and it seems like it's completely washed out in these later model runs.
And I guess it doesn't have a choice. It's like that little wave that gave us the rain yesterday morning and afternoon. It gets thrown into the entrance region of a confluence zone. It just gets shredded.
Yep.
There's no way it can maintain its geometric integrity, and that is a lot for what happens downstream.
That's right. Yeah. So could we go back to, well, let's keep the 500 look. We can see more of that. If we go to, let's go to 48 hours, I think, at 500. We can see the elongation of this vorticity strip. But there you go. You have a nice ball of vorticity, but it's coincident right with the geopotential low at 500. And so I'll keep my cursor right here. If we could go to the surface map at 48 hours, we'll see we lose that clear, strong signal of PVA of the thermal wind. It's still almost at this time directly over the center of the storm, but it's largely beginning washed out. It's beginning wrapped up, and the system becoming stacked. You lose your forcing, and as a consequence, we see this is the strongest time for this storm. I think it's 977, I want to say. But it'll weaken after this, and you can see that our cold front has not made much progress. We're still in the cold convection with this high pressure bringing flow from the north over our region, and there's still that band of precip that is sitting from Texas all the way into Ohio at this time. And this is an important time. I want to point out two things. First, look at these thicknesses. So if we follow this thickness line and trace it all the way back to where it's connected, it goes all the way up to the Arctic Circle. So these are temperatures, if you're sitting up in the Arctic Circle, I don't know why you would be. You go all the way down to North Dakota, I don't know why you'd be there either. But you're the same temperature, largely, in this column of air. So that's how cold this air is. It's almost the coldest air in this entire look at the hemisphere, with the coldest air being centered right over north of Hudson Bay at this time. But these are really cold thicknesses. And if you look over our region, we are right over the 540 line, a proxy for rain snow, and there is precip being highlighted for overnight Saturday into Sunday morning. And so while we're celebrating, I said this last week, Ohio State losing, that's always a good thing. There might be snow falling over our region. And I want to, if we go to pivotal, we'll look at the same time, if we could. Because this has been a feature that's been in multiple model runs. And I think we were at 48 hours should show it. That's a little too far, I think. Let's go to 42. Yeah, 60. So in this model run, this is the updated model run, there is a band of snow being forecasted by the GFS. It's more over Iowa into Nebraska. If we go to 45 hours, we'll see that snow is just north of Madison. If we go to 48 hours, we'll see we're into snow, and this is now 7 a.m. on Sunday. And if we go back to the 42 hour and just look at past model runs, we'll start at like Thursday 18Z. Here's snow being forecasted over us. We'll just step forward. Friday 0 UTC, snow, and then 6 UTC Friday. Again, snow. So this is a signal. I mean, this is weeks light snow, if anything. Probably not accumulating. But this is a decent signal for snow flurries for Saturday night into Sunday. Might wake up to a dusting of snow. I think if we go to 54 hours on this run, we can see it persist for about 6 hours or so in all of these model runs. So something to keep in mind. Might wake up Sunday and see some snowflakes, at least on the roofs, elevated surfaces like that. And then my final thing I want to touch on, if we could go to the temperature map. So you'll see we're right on the 32 degree line in the blues. This is Sunday morning. Let's go to 78 hours. So this is now the day before Halloween. We get into the low 20s overnight. 24, there's 23. So very cold mornings. And then if we go to 102, this is now Halloween. And we'll go to, I think, we'll go to 111. This is around maybe the start of trick-or-treating, if we could hover over the... We're at 36, 35 degrees. We go to 114. This is 7 p.m. now. We're below freezing for Halloween trick-or-treating. And I would always get mad at my parents because they would make me wear coats over my costume, and it would ruin the costume. So I'm sure that's going to happen for trick-or-treaters.
Is it going to be? It's not going to be raining, though, right?
No. We could look at that. We could just pull up the precip type and rate.
At least it'll be dry.
Yeah, nothing for that. Maybe lake effect snow.
Yeah, Fort Wayne and Chicago.
Yeah. But largely high pressure. We'll stay in cold advection for a while. Highs in the 40s all next week. Monday and Tuesday look like highs in the 30s. So It'll be a fun break from what's happening right now, especially in this room.
I am 100%.
That's cooler, zero.
Yes. Are there any comments or questions or anything? Yep.
Is there any inclusion of the jet?
What's that?
Is there any inclusion of the jet?
Oh, the jet stream? I don't believe so. I think it's in this. Yeah. It's in this one. I'm not sure why there's two. 300. And we'll go back to Sunday. Yeah, 12Z, roughly. So I mean, there's a jet, and it's a massively wide jet. It's very strong, but there's not any. The gradient of the winds as you increase towards the jet and away from it, there's not a clear like entrance-exit region that you would expect strong vertical motions to be forced by that. And we're centered right in the middle of this jet, so this is largely just telling you where the cold air is.
That could still work if we had warm convection along the axis, but we don't know that from just the heights of the wind, so.
That's right. We could look at that. I think temperature and wind should be able to show that. Does it go
They
that
don't go that
high?
high, no one ever thinks about that.
Yeah, it's all largely the same. Most likely no. Yeah. And then I guess we could end, let's look at the winter weather. Let's just see how much is forecast snowfall. We'll do 10 to 1, we can just do total. And I think let's step, just so we're past the snowfall, maybe 60 hours. And so, I mean, areas to our north might be an inch, but we're, this is just a dusting of snow for, if anything. But I mean, areas in Nebraska, we saw winter weather advisories, upwards of 4 inches, and you can see the snow band of that storm stretching from Ontario, Quebec, into maritime Canada. Yeah, what was that, 25 inches in Colorado? But that's nothing, that's the mountain, so that's every day in winter.
Right.
All right, well, thank you, Pete. Good job.
Thank you.
Okay.